Hi, I'm Lamiya Mowla. I am a Dunlap Fellow at the Dunlap Institute for Astronomy and Astrophysics.
Hello, I'm Kartheik Iyer, and I used to be a Dunlap Fellow until recently, and now I'm a Hubble Fellow at Columbia University. The sparkler is our name for a galaxy that we saw in Webb's first deep image. It is a really distant galaxy whose light has been traveling towards us for the last 9 billion years or so. And it sits right behind the massive cluster of galaxies that we see in this image. And because of an effect called gravitational lensing, the light from the sparkler gets magnified and distorted on its way towards our telescope. The sparkler is a really interesting galaxy because it's been magnified by a factor of 100. And when seen with JWST's incredible resolution, we see all of these tiny dots in and around the sparkler that we call sparkles. Analyzing these sparkles tells us that they are some of the oldest star clusters that we have seen in the distant universe.
The Canadian Extragalactic team, we were all gathered around in Halifax at St. Mary's University. And we are called CUNUX, which stands for Canadian Nearest Unbiased Cluster Survey, CUNUX. We all were gathered around because we wanted to go through the first image from JWST together. So it was around 7 p.m. We were all gathered around in the Astro Lounge, just waiting to see the first image come out. And when it finally appeared on screen, we were amazed, all of us, by the amount of details that we could see, all these different galaxies with all the different structures. We were amazed by all the things that we could see on the image. So the next morning, we are all looking at the images, going galaxy by galaxy, trying to figure out what's going on. And the one galaxy that really caught all of our attention was this galaxy with this really sparkling dots around them. So we immediately named it the sparkler because it was so sparkly. So when we saw this galaxy with this incredibly sparkly star clusters around them, one question that arose among the team was that, are these very young star clusters or are they old star clusters? So young stars are very bright, and these star clusters were bright, so we thought that this might be young. But then they were also red, and old stars tend to be red. So there is also indication that this might be old. So hence a bet went off between the team. It was like, are these young star clusters or are these old star clusters? And there were some very exotic chocolate on the line. And then Kartheik and I, we dove right in analyzing, trying to figure out, are these really old star clusters or are these young star clusters?
The question of whether these star clusters are young or old is important because it has implications for how we think galaxies evolve. And to determine this, we use the observations from JWST, which looks at the same galaxy across a range of different wavelengths to make an estimate of the brightness of the galaxy across a range of wavelengths, and this is called a spectrum. The spectrum allows us to analyze stars of different ages, because young stars tend to peak in the bluer parts of the spectrum, while older stars tend to peak in the redder parts of the spectrum. And so, as a team, we have developed all of these tools to disentangle the contributions to the spectrum from stars of different ages. And so, doing this with the light from just the sparkles, we were able to precisely age date them and find that some of them are really old. In fact, they formed just 500 million years after the Big Bang, or so we think. When we look at nearby star clusters, we can actually resolve them much better. We can see individual stars in these clusters. But because the universe is much older now than it was at the higher redshift when we see the sparkler, it's much more precise when we obtain an age for the clusters in the sparkler. And it's really incredible that these sparkles are so young in the sense that they formed so quickly after the Big Bang.
So JWST's, one of its primary mission was to find the first stars or the first galaxies. So to have observation from the time when the universe was just cooling down and the first stars that we, of all the stars that we see today, the first stars were just getting born. That's why a lot of the observations that we're doing now are looking at the very, very, very distant universe. The sparkler is a little different because it is actually a closer universe. We're not looking at the earliest parts of the universe, but we're finding something that is old in a young universe, which means that it must have been born at the very early days, or else you cannot find something old in a young environment. And that's what makes sparkler interesting, because this is not necessarily what JWST was built for, but it is working towards the motivation of the telescope, which is finding the first stars and the first galaxies. So finding something old in the nearby universe is not remarkable because our universe right now is old. But finding out how old these things are, that is a challenge. It is almost, if you think you have a cat and you're trying to figure out, is this cat 12 years old or is it 14-year-old? Just from looking at the cat, differentiating between 12 and 14 years old is really hard. But if you are looking at a cat and you're asking, is it 2 months old or is it 2 years old? That is easy, because a 2-month-old looks very different than a cat that is 2 years old. So that's why we are trying to find things that are old in a younger universe, because at that point it is easy to differentiate between something that is just born now and something that has been born a long time ago, as opposed to finding it now and asking, is this star cluster 13 billion years old or is it 11 billion years old? That's a hard question. Everything that HST has seen so far is galaxies aging and evolving over time, whereas what JWST wants to find is to observe as the stars and galaxies are being born and forming most of their stars. So that's the era that JWST wants to find. And it's important because that's where most of the action happens.